For question 2a, we want to solve this equation here and to give our answer in the form re to the I theta, which is Euler's form. So we're going to use de Moivre's theorem to help us solve this. So in general, if we're going to take the nth root of a number, we can take the following steps, which I'll put up on the right-hand side of the screen. Okay, so we've got some number z to the power of n, which is equal to w, which is in this form here. We can start by rewriting it like this. So we will have theta plus 2k pi for our argument. And we're doing that because, well, for any complex number, the argument is not unique. So for any two arguments of a complex number, they'll differ by an integer multiple of 2 pi. So now I've got it written in this form here. We can just use de Moivre's theorem to take the nth root of both sides. So then our roots are z sub k, which is equal to this expression here. And that's where k is equal to 0, 1, 2 up to n minus 1. Now just with that, we can note that k doesn't have to be equal just to 0, 1, 2 up to n minus 1. We don't have to start at 0. In fact, any n consecutive integers will work. So for example, for our one here, n is equal to 2, we've got z squared. So we could take k is equal to 0 and 1, that will work. Or we could also take k is equal to negative 1 and 0, will also work. We just have to choose which integers for k are going to work best, because generally we want to keep our argument of our complex number greater than negative pi, but less than or equal to pi. So now we'll go and solve our equation here. So we have z squared is going to be equal to 4 times e to the pi over 2 times I, and we can write that as 4 times e to the I pi over 2 plus 2k pi. So now using de Moivre's theorem and just taking the square root of both sides, we're going to get z is equal to the square root of 4 times e to the I pi over 2 plus 2k pi all over 2. So now I'm just going to write this argument here just over a common denominator. So timesing top and bottom through by 2, we'll just get z is equal to, well, square root of 4 is just 2 times, so we get 2 times e I to the pi plus 4k pi all over 4. And that is going to be for k is equal to, I'm going to pick negative 1 and 0. You could pick k is equal to 0 and 1, that's fine, and you'll get the correct answer. I'll just pick k is equal to negative 1 and 0 because I want to keep the argument between negative pi and pi. So the first part, so for k is equal to negative 1, we'll just plug negative 1 where we see k in, so we're going to get z is equal to 2e to the I, and well, 4 times negative 1 is negative 4, so we're going to get negative 3 pi over 4, which equals 2 times e to the negative 3 pi over 4i. So that's one of the roots, and the other one's going to be for k equal to 0, or we're just going to get z is equal to 2 times e times I to the pi over 4. We can write it like that if we want, doesn't really matter. Okay, so there are our two solutions there. Okay, so if you took k is equal to 0 and 1, then this one here, if you plugged in k is equal to 1, you'll get 5 pi over 4. Okay, so that is question 2a.